Hey guys, so today I'll be talking about problem 70, LeetCode problem 70, titled Climbing Stairs. And I'm not gonna reread the problem. You can read it on your own time and come back when you finish reading it and understand what's required. Basically, that's a problem. I'm just gonna jump into the solution directly. Okay, so the problem is telling you if you have a staircase with n number of steps, with n steps, okay? How many different ways you can climb all the way to the top? Given that you can only jump in 1 or 2 steps. You can only take 1 step at a time or 2 steps at a time, and that's about it. Okay, you cannot do more than that. You cannot take a bigger leap than that. So for example, if you look at this little dude over here, the problem is telling you he can just take 1 step and then another 1 step, or he can just take one big leap of 2 steps. Okay. So if you count how many ways this little guy managed to get to the top, he can take 1 step and then another step, 1 and then 1. That will give you 2 steps. 1 plus 1 is 2. He could just take one big jump of 2 steps. Okay. So you notice the numbers inside these parentheses will add up to the number of steps in the staircase, right? Okay, let's look at the one on the right side. Well, this guy on the right side can go 1 step and then 1 step and then 1 step, or he can do 1 step and then 2 steps, or he can do 2 steps and then 1 step, right? So let's write them down. He can take 1 step and then 1 step and then 1 step. The summation is 3. He can take 2 steps and then 1 step. Summation is still 3. He can take 1 step and then 2 steps. 1 step of size 2. Okay, so you notice every single parentheses of these, one of these parentheses, the summation of the sequence inside it is 3. Okay, because you're going all the way to the top, so you're covering the whole staircase. Okay, so far so good. Now, what's the problem? Can we do this for every single n? Like it seems like it's a lot of work, right? Like if we do this for n equal to 4, well, if you try to do it again, well, you could do 1, 1, 1, 1, which means this guy will take 1, 1, 1, 1, or he can do 2 and then 2, or he can take 1 step and then one small step, one big step of size 2, and then 1 step, and then, or he can take 1 big step, 2 more small steps, or he can take 1 small step, 1 small step, and 1 big step of size 2. Okay, let me, I'm gonna rearrange these sequences. Yeah, I think that looks better now. Okay. Oops. Okay, and I'll tell you in a second why I'm rearranging them that way. But hopefully it's clear by now why did I write these parentheses in that way. Which means if you notice each one of these parentheses, the sum of the numbers inside will be equal to 4. Okay? So here it sums to 4, sums to 4, sums to 4, and over there sum to 3, 3, 3, sums to 2, 2. Okay, now for n equal to 5, well, how many different ways I can get all the way to the top? It's gonna be a lot. And you should not be trying to brute force it. You should try to think, can we recycle any of all the answers to see how many ways we can get to 5? What do I mean by that? Well, let's just list all the possible parentheses. I'm gonna put a bunch of parentheses for the possible different ways to get to the top. I don't know how many, to be honest, but I'm just gonna write empty parentheses. If you look at each one of these path, each path over here, every single path has to end with 1 or 2, right? Because you can only jump with a step size of 1 or a step size of 2. So every one of these parentheses or path, each parentheses represent a single path, will end up with a number 1, with like value 1 or value 2, okay? Which represents the step size. Same over here. Some of them will end with 1. Some of them will end with 2. It has to be either 1 or 2. It depends on what's the size of the last step you took, or the little guy took. So for a staircase of size 5, I know for sure some of these sequences will end up with 1 at the end. Okay, I don't know how many. I'm gonna maybe stick 3 ones. I know some of them will end with 2, the very last step of size 2. Okay, it's either a step size of size 1, a step of size 1, or the step size 2, right? You can either jump 1 step at a time or 2 steps at a time. But I also know for sure that whatever numbers I'm gonna write over here, they have to sum up to 4. Why is that? Well, the sum of this sequence has to sum to 5. The summation has to equal to 5. And if 1 is the very last number, that means this have to sum to 4. Or maybe I can just say sum equal to 4. Okay, the summation has to equal to 4. Okay, same here. Whatever sequence I'm gonna list over here, the sum has to equal to 4. Because the last number is 1, and the sum of the whole parentheses have to equal to 5. Okay, same over here. The sum has to equal to 4. Whatever numbers I'm going to list there, they have to sum up to 4. And over here, the last number is 2. I know for sure each one of these parentheses has a sum of 5, sum of 5, sum has to equal to 5. Should be sum. That means whatever sequence I'm gonna write over here has a sum of equal 3. Sum has to equal to 3. Okay. Okay, so I'm looking for a sequence of numbers of 1s and 2s, sequence of 1s and 2s that give me a sum of 4. Do I have that written anywhere? I do. Where? I have them over here. These are sequence of 1s and 2s. They sum to 4. Each one of them has a sum equal to 4. Each one of these parentheses has sum equal to 4, which exactly what I need over here. I can use these guys to populate the answer here, and here, and here. Okay. So basically, I can recycle my old answers. What about I'm looking for a sequence of numbers that give me the sum of 3? Do I have that written anywhere? Oh, I do actually. Where? Oh, over here. Each one of these guys, they sum to 3. Sum equal to 3. Which means I can recycle my old answer and populate it here. And here, here, and here. Okay, so what does that mean? So when n is equal to 5, how many different ways I can get to the top? Well, that will equal to how many different parentheses ends with 1 and how many different parentheses ends with 2. Okay, well, how many different parentheses gonna end with 1? It will be the same number of parentheses that sums up to 4. Okay, and how many different parentheses I have end with 2? It will be the same number of parentheses that has a sum of 3. Okay. Okay, so what am I trying to say? What I'm trying to say is the number of ways for here case of size n that would equal to the number of ways for staircase of size n minus 1 plus a number of ways for staircase of size n minus 2. Again, why is that? If you look at when n equal to 5, I need to use the answer that I got when n was equal to 4. And I also need to use the answer that I got when n equal to 3. Here, the answer I got when n equal to 3. And over here, I'll write it a little bit nicer. The answer that I got when n equal to 4. Okay? N equal to 3 and n equal to 4, I collect their answers and I form my new answer for n equal to 5. Okay? That's the whole idea. Okay, so how can we write this more elegantly? I'm gonna use the letter F to represent, or to represent the number of ways. I'm gonna say F is F as a function, F of n, that will be number of ways for staircase of size n. Okay, so if I'm gonna rewrite what I wrote earlier, that means f of n will equal to f of n minus 1 plus f of n minus 2. That's basically what I wrote earlier over here, but I wrote it in a more mathematical way. Just wrote it more elegantly. Nothing different. This is basically the whole idea. That's the whole idea. Okay. We call this recurrence relation. Okay. Call the recurrence, or you can call it or recursion, recurrence, whatever you call it. Okay. And but this is the whole idea of the problem. This is the whole idea of how to solve this problem. There is, of course, other ways to solve it, but that's the first solution I'm going to discuss, which is if I want to find the answer, the number of ways for a staircase of size n, I need to recycle my answer when the staircase, or if a staircase of size n minus 1, and recycle the answer or reuse the answer for a staircase of size n minus 2. Okay. Okay, so that's the intuition behind where this recurrence relation came from. And again, to reiterate how do we got it? If you have staircase of size n, when you have a size n, so you have this staircase size n, the last number either ends with 1 or the last number ends with 2. Okay, that's the whole idea. It ends with 1 or 2. There's no other numbers. Why is that? Because the problem tells you you can either take one step or one big step of size 2. Okay, so one step of size 1 or one big step of size 2. So the last number is 1 or 2, which means the rest of the sequence here has to sum as a sum of n minus 1. Okay, and this whole parentheses has a sum of n. Similarly, this guy has to give you a sum equal to n minus 2, because the whole parentheses has a sum equal to n. Okay, so basically I'm looking for all different ways that I can sum up to n minus 1, and I also look in all the different ways to get a sum equal n minus 2. And that will give me every single parentheses that eventually sums to n. Okay, that's the whole idea. All right, so what else? What else I want to say? Yeah, there is an issue performance-wise with this recurrence relationship. Specifically the runtime. This the runtime will be inefficient. Why is that? If I were to give you n, trying to calculate the number of ways for a staircase of size n. So in that case, f of n. We said earlier it will be a summation of the number of ways for a staircase of size n minus 1, number of ways for a staircase of size n minus 2. Okay. And, well, this guy over here, it's actually, I'm going to put numbers. I think that will be a lot easier to grasp. If you have a staircase of size, let's imagine maybe 7. If I want to calculate the number of ways for a staircase of size 7, it will be the number of ways for a staircase of size 6 plus number of ways for a staircase of size 5. Sorry. Yep, I'm going to put two separate branches. Okay. Okay, what about number of ways for a staircase of size 6? Well, that will be the number of ways for a staircase of size 5 plus number of ways of a staircase of size 4. There's a plus sign here, there's a plus sign here. Over here will be the number of ways for a staircase of size 4 plus number of ways for a staircase of size 3. Okay. Okay, one more, and I think you'll get the idea. Well, this guy will be the number of ways for a staircase of size 4 plus the number of ways for a staircase of size 3. This guy will be the number of ways of staircase for a staircase of size 3 plus the number of ways for a staircase of size 2. Well, this guy, number of ways for a staircase of size 3, number of ways for a staircase of size 2 plus it will be, okay, f of 2, f of 1 plus. Now, if you see the problem here, you are redoing computations. This tree branch, this subtree, is the same as this subtree. So you're redoing a lot of work. So like a whole subtree, you're redoing it. That's lots of computations. And mind you, this is for staircase size 7. If that was size 100, it will take forever. Okay. Also, if you look at this subtree over here, this is literally the same subtree over here. F of 5. If I finish it, if I keep doing it, it's the same one. So I'm basically redoing the same problem over and over, or sub-problem over and over. That's not efficient. And that's not gonna, let you pass the interview. Okay, so that's an issue. We are redoing sub-problems, okay? When I say sub-problems, I'm talking about the subtrees, okay? So in that case, we're redoing this guy, which is the same as that guy. And that's a waste of time, memory, yada, yada, yada. Okay, so in the next video, I'll be talking about how can we make it faster, but that's the idea, okay? So it's called, there's a fancy way of, this concept has a fancy way called DP, or they call it dynamic programming. It's just a fancy way to say recursion with little extra stuff on top, but it's just recursion. Like really nothing fancy about it. And it's a scary concept for many people. And I think it's scary because lots of people, they don't really make sure they have a strong grasp of recursion. So that's why DP is usually like a nightmare in interviews. It was a nightmare for me too at some point. But once I got the hang of recursion, it made a lot of sense, okay? Okay, so to recap, that's the focus of the first solution. There's actually multiple ways to solve that problem, and I will go over each one of them. But this video, I was just trying to give you the intuition for why this is a recurrence relation, okay? Okay, so I'll see you next time.